Let's look at some examples from our notes. So in this problem, an election ballot asks voters to select 5 city commissioners from a group of 20 candidates. So that's our total. That's our N, and this is our R. In how many ways can this be done? So, as said before, we are going to use our calculator using the combination button, NCR. And so we now need to plug in those numbers. So N is our total number, so that's our 20. Then the C, and then 5 is our R. And so we know that order does not matter, right? So order is no. So that means it's combination. So when order doesn't matter, we use combination. Because if we chose, so for example, 1, 5, 7, 9, and 20 as our 5. And then we do 5, 7, 9, 1, and 20. We choose those numbers in a different order. Aren't they the same 5 city commissioners? So that's how we know order does not matter. So let's plug it into our calculator using the steps from the previous video, but I'll show you one more time. So if we're using the TI-30 or TI-33, it'll be very similar. So we type in our number, the 20, and then here we have probability, go down to NCR, and then type in our 5. And so our answer is 15,504. And I'm going to show you again on the TI-84. So if we type in our 20, then type in math, scroll over to probability, and then go down to the NCR, hit enter, and then our R was 5, and we get the same answer. So 15,504. So 15,504 ways. All right, so let's look at number 2. How many ways can a 3-person subcommittee be selected for a committee of 8 people? So 8 people is our N, and subcommittee, the 3. Now, does it matter the order? No, so we can use our combinations. So our formula is NCR for the calculator. The N is 8, then the C, and our R is 3. So when you type that in on the calculator, you will get 56. How many ways can a president, vice president, and secretary be chosen from a committee of 8 people? Does order matter? Yeah, you can be chosen for president or secretary. So this is our counting principle. So this was the combination because order didn't matter. And the second one is our counting principle because order does matter. Secretary is different than vice president or president. So we do our 3 lines. So no repeats, right? You can't be president and secretary. So no repeats. So how many people do we have? We have 8. Well, if John is selected for president, he cannot be selected for the others. So how many left? 7. Well, if Susie and John were selected, can they be secretary? No. So how many are left? 6. So when we multiply all together, you get 336. All right, our last example for this unit, an electronics store receives a shipment of 30 graphing calculators, but 5 are defective. 4 of the calculators are selected to be sent to a local high school. How many selections can be made? Well, we don't need to take out defective for this first one. So this is, does order matter? No, they just want us to select. So this is combinations. So our N, C, and R. So our N is how many total? 30. Put your C. And then R is how many are being sent? 4. Plug it into our calculator, and you get 27,405 ways. Order does not matter. All right, for number B, how many of these selections will contain no defective calculators? So we need to take out our defective calculators. So we have 30 total. I know that 5 of them are defective, so throw those out. So how many total do we have left to choose from? So that is our N. So our new N is 25 without the defective. So you put it in your calculator as 25C, and then how many are chosen for each high school? 4. So when you plug that into your calculator, you get 12,650.